So simple stuff here, hopefully at the start. Identify the transformations, the shifts from the original to the following. Basically, we're just asking what direction are these two shifts going to be. So again, inside is left-right. It's the opposite of what we would think. So right 4. And out here is my up-down. And it goes along with what I would think. So that'd be up 3. That's all I need. You're like, sweet. Now, be careful on this next one, because I even find myself making a boo-boo. Identify the amplitude and period for the following. We're so used to doing amplitude first that I'll have a person put 3 here, and I'll be like, no, that's the period. Oh, amplitude's over here. Amplitude, always positive. The period is not asking just for the B value. Yes, I need the B value. But to find the period, it's 2 pi over B. And if that would reduce, I'd reduce it, but this one doesn't, so I won't. But again, a lot of these, there's some simple stuff that's going to be coming. All right, let's see here. Error analysis. A student looked at the graph above and wrote that the amplitude of the function is -3. Describe and correct the student's error. Okay, so if the amplitude isn't -3, what is it? It's 3. So what's the biggest dilemma with them saying that it's -3? Yeah, amplitudes cannot be negative. So, for instance, this would be a 2-point type question on the post. One for giving me the correct amplitude and one for telling me why they're a little goofy and what their thought process is. I mean, I can see, because they're like, well, down here, -3, but yeah, definitely not correct. In a town with a large convention center, the cost of a hotel room has increased 3.8% annually. If the average hotel room cost $37 in 1990 and this growth continues, create a function. Don't solve it, just create a function that models the exponential growth of the room price starting in 1990. Okay, this is where I got to dig a little bit into the memory bank here. When we're doing just basic growth or decay, that's the little mini formula we're playing with. Where A is my starting value, in this case 37. And then in this case, since it's increasing, that'd be plus. This has to be in its decimal form. If you forget about that, divide this by 100 and you'll get it. But otherwise, we'll get that in there. And I don't know the time. Okay? I don't want to use 1990. I'm keeping this general, where if I was told a time, let's say it said, now solve if the room was in 2015, I could put in 25 for t and get my answer. But I don't need to. I'm just creating a function. So definitely read carefully so you're not doing more work than you need to and then ended up getting it incorrect anyway because, well, you didn't read. All right. The depth of the ocean at a swim buoy reaches a maximum of 10 feet at 6 a.m. and a minimum of 4 feet at 6 p.m. Write a trig function that models the water depth as a function of time t. Assume that t equals 0 represents 12 a.m. Okay, this is going to be a 4-point question. Because when I'm doing this, it's going to be a sine function. I'll give you that in advance. We're not going to have any phase shifts here. But what we're looking for point-wise is, can you find A, can you find B, can you find C, and can you graph it? So to find A and C, to get yourself a couple of quick points, this is going to be pretty easy. What we're going to do is I'm going to take my max, which is at 10 feet. I'm going to take my min, which is at 4 feet, and I'm going to use that to find my midline, my C, and my amplitude, my A. So as we're doing those, thank you. So to find my midline, I'm going to add my max and my min together and divide by 2. In other words, I'm finding the mean. I'm finding the average. And whatever that is, that's going to be my C value. So I'm going to have a shift of up 7. My amplitude is the exact same values, except now I'm subtracting them. 10 minus 4 is 6, divided by 2 is 3. That's my A value. And this is just an application of some of the stuff that we were doing before. So as far as this goes now, the only thing I'm looking for is B. Now that's a little more interesting. I've got to work my way around this a little bit. So let's just say, for instance, that my B was 1. It was normal. This was my graph. So if I went and I started to look at graphing this, I'm like, okay, the max is going to be up at 10. The min's going to be at 4. And I'm deciding I'm just going to count by 2s here. Just because that kind of seems to be the pattern that I'm working. I don't know what these are yet, because I don't know what my period is yet. So I start to think about this, and I'm like, okay, if I were working this like I normally was, what I'd be pondering here is a normal sine curve goes 0, 1, 0, negative 1, 0. That's the pattern. But I've got some things that are going to adjust that. I've got an amplitude, my 3, which I'm going to have to do first. So all of these, I'm going to multiply them by 3, but then, once I do that, I also need to add 7. I got to do both. So I start working through here, and I'm like, okay, so 0 times 3 is 0, plus 7 is 7. 1 times 3 is 3, plus 7 is 10. 7. Negative 1 times 3 is negative 3, plus 7 is 4. And then back to 7. But here's what I want you to notice. The two numbers that aren't 7s are 10 and 4. Not a coincidence. So when I go to graph these, even though I don't know these yet, my first point would be at 7. My second point's going to be at 10. Back to 7. Back down to 4. Back up to 7. Okay, that's what my curve would look like, representing this buoy that's floating out in the ocean. So you're like, okay, still don't have the period though. Here's where I get that from. Now I look back at the times. Maximum of 10 feet at 6 a.m. Okay. Since we're starting at midnight, 6 a.m. is 6 hours later. Now I could just take that pattern and run with it, because we know as we go to the right, it's going to keep going up by whatever this first value is. So 6, 12, 18, 24. But if I wanted to double check, let's look at the min value here. The minimum's at 6 p.m. How many hours after midnight is that? Well, midnight to noon is 12, and to 6 p.m. is another 6, which is 18. There's my minimum. So you're like, okay, so now what? Well, if my period's 24, I need to know B. So 2 pi over B equals my period. I can make it a proportion if I want to. And I can cross multiply and reduce the coefficient part of my fraction. Now, even if you're like, okay, I was with you until you started doing this craziness. I can do this, I can do this. Cool, if you just do those things, you're getting 3 out of the 4 points. But don't look at it and go, oh, no, and quit. At the very least, make sure you get this stuff done, because at least that's going to get you 2 of the points in the deal. So just kind of look back through that a little bit, because a lot of the stuff you've seen and you've done, it just may not have been quite in that format. All right. Identify the domain and range of the function. This is a growth function. My b value is greater than 1. For any growth or decay, domain is always the same, negative infinity to infinity. And I'll show you how to look at this graphically too here in just a second. Your range normally is 0 to infinity, unless there's a vertical shift at the end. If that happens, that just changes your 0. -5 to infinity. If you're like, I don't remember stuff like that, not a problem. If I forget, I just go here. I type in that, and I can look at the picture of it, and I notice what value is it going towards and kind of evening out at? -5. Goes up forever. Goes forever left. Goes forever right. So I can visually see it too, if I kind of forget that a little bit. And number 7 goes right along with it. Different question, same idea. End behavior does the same thing. Any growth function, well, decay function too, x is -infinity to infinity. There's a direct correlation between domain and these values. Just like there's going to be a direct connection between range and these values. But there's no plus or minus over here. So my range is 0 to infinity here. Now, I got to figure out which one gets 0 and which one gets infinity. Think about it for a minute. Growth looks like this. So as I'm going to the left, am I getting closer to 0 or infinity? It looks like I'm getting closer to 0. As I go to the right, I'm going up, 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 up towards positive infinity. But again, if you're more visual, type this in the y equals like we did with number 6 and look at the picture. But these two guys will always be the same. I don't even have to think about that at all. The other part, the only part that might change a little bit is my f of x. Because again, f of x is a fancy way of saying y equals. Sketch 2 cycles of the graph, not just one. We'll start with one, but then we'll expand here. So I look. I'm like, okay, my a value is -2, and my b value is 1, so my period is going to be 2 pi. Because 2 pi over b, 2 pi over 1, it'd still be 2 pi. So 2 pi and pi. It's just my normal one, so I shouldn't have to do too much thinking here. But here will come the moment of truth for some of you. My amplitude cannot be negative. That is true. That's not what's being asked here. I'm graphing this. Is my graph going to start at 2, 0, or -2? Cosine would have started at -2. Sine always starts at 0, okay, unless, again, we have some sort of a shift. Okay, so let's ask the question again here for the next point. Okay, I'm at 0. Am I going up to 2 or down to -2? We're going down. In sine's case, that a value is telling me where that second point after 0 is going to be. So down and then back up. So it basically flips my normal sine graph. I connect those. That's one cycle. Like, oh boy. So now I need 4 more lines. Now the graph part shouldn't be bad to do because the pattern just keeps going. 0 min, 0 max. 0 min, 0 max, 0. And I end up back at the same place I started. Okay, that's good. But I got to make sure I label the axis too. So here would be my suggestion. A pattern develops, and we talked about this up in number 5. This is how much we're going to go up every time. So if I look at this like it's a fraction, like it's a half, it's just going to keep going up by a half all the way across. And you notice what happens. 2 over 2 is 1. 3 over 2 doesn't reduce. 4 over 2 is 2. And I'm just going to keep right on rolling with this. Now I just got to get the pi's back in. Does 5 over 2 reduce? No. 5 pi over 2. Does 6 over 2 reduce? Yeah. 3. 3 pi. 7 over 2 reduce? Nope. About 8 over 2. Yep, 4 pi. And it just doubles up, which makes sense. So again, details, details, details. Watch if it's sine or cosine to see where you're starting. Watch the a value to see where that next point's going to be. But then just expand your pattern. Let it kind of roll that way. All right. Now this one, I'm going to admit, is weird. I'm not going to blame you if something goes cuckoo here. But it actually isn't as bad as it looks. Okay, the pressure P against the walls of blood vessels of a certain person is given by, and they give us this big fancy cosine function, where T is the time in seconds. If one cycle is equivalent to 1 heartbeat, that's where our key is going to be. What's the person's pulse rate in beats per minute? Okay, if 1 cycle gets me 1 heartbeat, so if 1 cycle, now, is the 1 cycle 5 pi over 3? No. My B value, though, is 5 pi over 3. So what do I need to find out? 1 cycle is 1 period. I need to know what the period is of this. Now, I don't have a picture to help me. So when I do this, I'm going to say, okay, so period is 2 pi over B. So 2 pi over B is 5 pi over 3. And I'll have people ask, well, couldn't I just do 2 pi divided by 5 pi over 3? Yes, but it's a fraction over a fraction. I think that's going to be harder. So I would just go this route. Set it up as a proportion, because I know what the formula for finding a period is. And divide both sides by 5 pi, because that's what's with B. So B is 6 over 5. So you're like, my period is 6 over 5, excuse me. Did I just do something silly? Let me look. That was silly of me. I did a pi. Okay, my B is going to help me enough, though. So that's going to get me through 1 cycle, because that's my P. That's my period. So my period is 6 over 5. You're like, okay, what's that mean? Well, here's what it means. It means a cycle is going to take approximately 1.2 seconds. So we want to see heartbeats per minute. So, 60 seconds in a minute, 1.2 beats per second, tells me there's going to be 50 beats per minute. That's going to be my pulse rate. Okay, so I'm going to take the value that's there to figure out the period. I flip my letters around. And whatever that is, we're just going to divide that into the 60. That one is strange. This is another one where take that value, find the period, that's where a majority of the points are going to be. So just, again, especially with that much time, show as much work as you can to make life as simple as possible. But if there's only a question or two in here that bug you, that's not a bad thing. Now we can get back to some normalcy. Simplify. All right. Anytime we see plus or minus, I'm putting parentheses, so I'm not thinking about doing silly stuff like trying to cancel those. Oh, dear. If you try to cancel those, you should get like negative points on that particular question, because we just got to know better. Divide means the fraction after the division flips. And if I can factor something, and we can factor this. Okay, difference of squares. What do I square to get each term? That's going to be what I put in. I square 2x to get 4x squared. I square 7 to get 49. And to get a negative product, I do plus and minus. This is the point now where if things are identical, I can cancel them. X plus 4s, 2x minus 7s. And then we get to the final moment of truth. I have x left up top. I have 2x plus 7 left in the bottom. Can I cancel the x's? No. That's bonded. It's in parentheses. It's like, nope, singleton, stay away. So I leave that be. Adding, same dilemma. I need a common denominator. Don't care about the numerators yet. I run through my little checklist in my brain. Do I have any coefficients out front? No. Do I have any single variables that aren't bonded out front? No. So I'm just going to take the quantities, the sets of parentheses that are there, put those there, put whatever was initially in my numerator up top, and I have to fraction build. And some of you have actually found a shortcut for a particular way of problem doing like this, but I'm not going to play the shortcut game here. Whatever it takes to get from my old to my new denominator, get it in there. Do not cancel. Old to new. Excuse me. Once I get those built, do not cancel out the denominator. This is not an equals. It's not an equation. Keep your denominator. Again, no word cancel has come up yet. We don't do that until we're completely together here. And so now I got to combine like terms. So I go ahead. I'm just going to distribute this out above here so I can save having to write it all out one more time. And once I've distributed, I'm going to combine like terms. So 6x and 4x is 10x. Negative 8 plus 18 is 10. And at this point, you have to use a little common sense possibly. You're like, okay, these are not the same. Am I done? Well, I do notice that I could factor a 10 out of these. Now in this case, is that going to help me at all? Well, not really, because even if I do factor out the 10, I don't have anything that's going to cancel. So in this case, either one of those answers would be completely acceptable for full points. But about the time you don't do this, and then it does factor out and something does cancel, you can be like, man. So I'd still try to get to this, but that's just me. Just me. We're going to deposit $1,000 in a savings account. Each year thereafter, you're going to deposit 13% more than the previous year. How much money will you deposit in all after 30 years? Okay, we're actually calculating this time. Same formula that we used earlier. I got some money. I'm depositing, which means it's going up in value. But this time, instead of using T or X, I know what T is. It's 30 years. I actually want to know, and I don't need to use the Y equals because I'm not looking for a whole bunch of values. I'm just looking for the value I need. 39, 115, 90. If you wrote 39, 116, I'm not going to tell you you're wrong. But again, always got to look to see what's being asked. This time we asked to solve, we worked it that way. Oh boy, another favorite, but it's a simple one. Ryan tried to verify the following standard, but he didn't do it correctly. Your job is to describe the error and complete the verification correctly. Okay, for the moment, I don't want to know what Ryan did because I'm going to do this right. Okay, tangent, you're like, oh boy. Tangent is sine over cosine. What about secant? 1 over cosine. But when I divide, I remember, okay, that makes the second one flip. So I've got sine over cosine times cosine over 1. And I notice once I do that, hey, I can cancel the cosines and I get sine. Okay, that's the right answer. Now let's look at what he did. Sine over cosine, okay, divided by 1 over cosine. See, he shouldn't have written it vertically. That's his problem, but we won't tell him that. But he got here. Why'd he get cosine squared? Oh, he didn't take the reciprocal of the second fraction. So, I mean, you could even say Ryan didn't flip, didn't take the reciprocal of second fraction. That's fine. So basically what Ryan ended up doing is he ended up multiplying instead of dividing. That'd be another way you'd be able to put it. As long as I can understand you're telling me, hey, this is what he didn't do, and I can kind of conjure up what you're talking about, we're good to go as far as that goes. But again, it'll be a simpler one like that. Don't worry, I'm not going to give you like sine squared minus cosine squared and make you figure all that stuff out. That wouldn't be very nice of me. Okay, more error analysis. Describe and correct and fix it. Again, I don't care what person did here. When it says I got to fix it anyway, I might as well just do it. So here's my question, though. What's my LCD? X plus 4. Because the X is a singleton. That's why I put parentheses whenever I see plus or minus, so I don't think it's just X plus 4 because I already see an X. So when I go to fix that, now that I've got the right LCD, I go, okay, I got the X plus 4. I didn't check off the X. I need that. Over here, I've got the X. I didn't check off the X plus 4. Do my little side distributing here. So I look and I'm like, okay, time to get down to one fraction. 3x and 2x is 5x. Plus 8. Can't factor that anymore. These aren't the same. I can't cancel. Okay, that's the right answer. Now I can start peeking to see what went wrong here. And I'm looking and I'm like, well, that was kind of dingy. Looks like he did times 4, but that's going to make 4x. So lots of things here. First, wrong LCD. Or that's even enough for me. I mean, you could say, why multiply by 4? Because even if you did, that's 4x. 4x and x plus 4 aren't the same thing. Okay, there's lots of ways you can tell me that there's a boo-boo that they made. So just find one, okay, and get that in there. But again, the main thing there is that you're going to show me you know how to do it right. Okay, solve. The big word from before, we're going to exponentiate. Log base 4, I exponentiate with that base number. And I am not doing that off the top of my head. 4 to the 6th power, not 4 times 6. Big answers are okay. Subtract the 2. And I'm good. 16, you have choices. I am going to guess, though, that most of you aren't going to change the base over here. You're going to use the inverse instead. We'll find out if I'm wrong. So the inverse of 3 is not to divide by 3, because that's an exponent. It would not work. But to take the log of base 3. This guy, I have to type in my calculator as a change of base. So if you type log of 27 divided by log of 3, you get 3. And all of a sudden, just with that one step, we've gone from craziness to a basic algebra 1 problem. Add my 1 over, divide by 3. Keep it simple. Whatever that base is over here, where the exponent is in my variable is in my exponent, excuse me, that's the logarithm I'm going to need to use. Another example, don't do too much work. What are the excluded values? What makes the denominator equal 0? I don't care about the numerator. I'm not building fractions. I'm not solving this. All I want to know is what causes a problem. X plus 3 can't be 0, so x can't be negative 3. Okay. X squared minus 9 can't be 0. X squared can't be 9. X can't be positive or negative 3. Well, I already got negative 3. I could factor that if I wanted to. I could do a difference of squares, x plus 3, x minus 3. That would also get me there where I could solve it. But one of those will work. But it's just values that make the denominator 0. Don't overthink it. All right, Full calculator problem. We got 2 job offers to figure our way out of here. You are given the models. Don't try to get creative and make up your own. Not a good idea. So what we're basically looking at is getting them both typed in and then looking at the chart. And what you'll notice is at the beginning is that the first column is bigger, okay, Campco. My job is to figure out how many years I have to go down until the second column gets bigger, and it does in year 8. So that answers the second part of the question. How many years later will Walby exceed? Now, which offer is best? I personally think the simplest way to say it is, if you're going to be there from 0 to 7 years, you want to go with Campco. They offer you more money. If I'm going to be there 8 years or more, I'm going to want Walby because they're making more money. Something that simple is enough. Just to kind of break that down a little bit. But again, nothing real bad or complex, just knowing where to put things and working those out. Okay. Now we're into the probability and statistics stuff. Okay, you're going to watch the study habits of 5 calculus students from the same class earning grades of A through F. Determine whether the following situation calls for a survey. Okay, survey, I want somebody's opinion. Am I asking for anybody's opinion? No, not a survey. An observational study. I'm just watching them. I'm not changing anything. I think that's it, but let me check. Or an experiment. I change something. So like if I'd have watched those students and I gave 2 of them a study guide and I didn't give 3 of them a study guide, now we're talking about an experiment. But I didn't change anything here. I'm just watching them. And that's all I got to do is pick one. Okay, don't create situations for all 3. Just do what the question asks. We want to survey a sample of customers at a fast food chain restaurant on food quality. Describe how you administer the survey. Justify your process is randomized and unbiased. Okay, let's pick a specific one so we can kind of lock in on this. Let's say Beefaroo is doing this. So if I went and did the survey only for Beefaroo customers, would that be legit? Not really. Because hopefully if you're going to Beefaroo, it's because you like it. So maybe, let's see, how can I administer the survey? Survey customers at 5 different fast food restaurants. So maybe I go to McDonald's and Burger King and Taco Bell and Beefaroo, and I'm just going to these different places and ask them in different spots. That'll even things out a little. Or an even better idea, now that I'm thinking about it. Survey the experts, for the most part, on fast food. Survey high school students. Don't even go to the restaurant. So they'll tell you what they think, and B, they probably have it more than any of the rest of us, just because it's quick and easy. So just come up with something like that. And again, randomized, unbiased. It kind of works its way in there with it if you explain your survey well. For a stats project, a group of students decided to collect data in order to approximate the percent of students starting at a community college instead of a 4-year university. They collected their data by interviewing students at Rock Valley College. Was this a good idea? Okay, I can almost guarantee it'll never be a good idea on a question like this. Okay, now here, explain a better method of sampling if you feel this was inappropriate. You can even on this explain why this is an inappropriate way of sampling. Why is it bad? Right, so all of these students go to a community college. That's not going to help us out very much. Now, I wouldn't want to go to NIU either, because now it's the opposite problem. So let's see. maybe survey high school seniors on where they will attend, sort of like they did a little survey thing here. Because now, again, you're going to get a little bit of everything. I mean, maybe you go to a local area as people go in and say, hey, are you going to college right now? No. Okay. Are you going to college? Yes. Oh, okay. Where are you going to college? You could even stand in front of a store and do it. People might look at you a little strange, but hey, you got to do what you got to do to get your information when you're doing this stuff. Harty's going to go on pause. Chart below. This goes along with what I was speaking with some of you at the beginning of class about what went over on our stats probability grace quiz. You've got to pay attention to the words inside the parentheses. Underweight and female. Find the combo, underweight and female. That's your success over the total. And the totals are already here. Do not add all of them up now and try to make totals, because now you're getting crazy. Okay? Male or overweight. Okay? How many males are there? There's 62 out of a total of 112 people. Overweight. 66 people out of 112. But be careful. There's one spot left to this. What about males that are overweight? What about my overlap? My A and B. Male overweight, there's 45 of them. Well, right now, those 45 guys are being counted with the males and the overweight. So now we're counting them twice. We don't want to do that. So we need to subtract that part out. Which would get me the actual probability. And then the last switch, we got and, we got or, then we have given. Given means what's afterwards. My B is the denominator. In this case, it's males. My numerator is both. Normal, male. No wisecracks. Normal weighted males, just not normal. So normal weighted males, there's 12. Males total, there's 62. So it's not going to be the 112 this time. That's not right. 5, Harty. Learn how to subtract. Learn how to divide. 5. No. 6. OMG. This is one of those Harty moments that I just can kind of laugh at myself. How ridiculous that just was. 12 divided by 2 is 5. Mm-hmm. Yep. And I'm not even from the calculator generation. I still do it. All right. Recording company, almost there, reviewed 3 surveys of people's music preferences. 1 reported of 200 questions, 45 preferred country. All right, so country, 45 out of 200. Second survey noted that 67 out of 160 liked hip-hop. All right. The third survey found that 16 out of 65 preferred rap. If you want to choose 2 acts to perform, which combination would draw the greatest number of attendees? Figure out which 2 of the fractions would give you the biggest values. Most of you, it's easier to make that comparison if you go to decimals. The 2 biggest decimals are the 2 most popular acts. So those are the 2 that you would pick. In this case, the hip-hop and the rap. And finally, error analysis. Survey asked 40 people where they learned about current events. What's the probability the person gets the news on TV given they are male? Okay, forget about what they're doing. Television, male. Male on the bottom. TV and male on top. Now this time I don't have a total, so I got to add. So 9, this could be dangerous. So 20 males. TV and male is 6. So the right answer would be 3 out of 10, if I actually get that on the screen. There we go. So now I look. Jackie's got 6 over 40. 40? Where's Jackie getting 40 from? Well, let's see here. 8 and 12 is 20. Oh, there's where Jackie's getting 40 from. So Jackie got the TV male part right. Jackie used male and female. Not a good idea, Jackie. Been hanging out with Harty too long, making mistakes on things. So that basically, ladies and gentlemen, is what you are looking at for this post. But take your time, show as much work as you can, and you will do super.